Welcome back to the Curious Cub Exam Booster. I'm your host, Dwayne Johnson. Today, we're diving into the world of motion and time, two forces shaping everything around us. Motion is simply a change in position. If you move from the couch to the kitchen, that's motion. Kicking a soccer ball? That's motion too. Everything in the universe moves. Planets, cars, even atoms. But motion always happens over time. It takes seconds to walk, or for a ball to reach the goal. So, motion is the change in position, and time is how long that change takes. We'll break down types of motion, how we measure time, and how these ideas help us understand the world. By the end, you'll be ready to tackle any question about motion and time. Let's get started and become masters of movement. Titans, let's move. Not all motion is the same. Scientists group motion into three main types. First, linear motion, movement in a straight line, like a bowling ball rolling down a lane. Second, circular motion, movement along a circular path, like a merry-go-round or the hands of a clock. Third, periodic motion, motion that repeats in a regular pattern like a swing or a pendulum. Linear is straight, circular is round and round, periodic is back and forth. You'll spot these everywhere. A runner, linear, a spinning wheel, circular, a ticking clock, periodic. Recognizing these types helps us describe and predict how things move. So, next time you see something moving, ask, is it straight, circular, or repeating? That's the power of understanding motion. Keep your eyes open for these motions today. Let's keep going. Motion and time go hand in hand. But how do we measure time? Ancient people used sundials, tracking shadows to mark hours. Later, water clocks and hourglasses measured time with dripping water or falling sand. Mechanical clocks brought accuracy using gears and swinging pendulums. Periodic motion in action. Today, digital clocks use vibrating quartz crystals for precision. The most accurate, atomic clocks, which barely lose a second in millions of years. Measuring time lets us calculate speed, schedule our lives, and understand the universe. Time is our tool for mastering motion. Let's see how speed fits in. 10. Let's talk speed, the measure of how fast something moves. Speed is simply distance divided by time. If you run 200 meters in 40 seconds, your speed is 5 meters per second. The formula: speed and jaske distance, time. Use kilometers and hours or meters and seconds. Just match your units. This formula works for everything: snails, cars, even light. Knowing how to calculate speed lets you compare how fast anything moves. It's a key skill for any science champion. Ready to level up? Let's talk about steady and changing speeds. Does speed always stay the same? Not usually. Uniform motion means moving at a constant speed in a straight line, like a train cruising steadily. Non-uniform motion is when speed changes, speeding up, slowing down, stopping, starting. Think of biking through traffic. You start, stop, and change speed often. Scientists use distance time graphs to show this. Uniform motion makes a straight, sloped line, steady and predictable. Non-uniform motion makes a curved line, showing changes in speed. Just by looking at the graph, you can tell if motion was steady or changing. Let's recap and test your skills. Titans, you've learned a ton. Let's recap. Motion is a change in position over time. 3 types: linear, straight, circular, round, periodic, repeating. We measure time with everything from sundials to atomic clocks. Speed is distance divided by time, a formula you now own. Uniform motion is steady speed. Non-uniform is changing speed. Distance time graphs show the story: straight lines for steady, curves for changing. Now, let's test your knowledge. Curious Cub quiz. 1. A car driving straight at a constant speed is A. Periodic motion. B. Circular motion. C. Uniform motion. D. Non-uniform motion. 1. If a sprinter runs 100 meters in 10 seconds, what's their speed? A. 100 ms. B. 10 ms. C. 1 ms. D. 1000 ms. 1. Which is periodic motion? A. Ball rolling down a hill. B. Earth orbiting sun. C. Child on a swing. D. Car stopping at a light. 1. On a distance time graph, a curved line shows A. Not moving. B. Constant speed. C. Speed is changing. D. Moving in a circle. Keep practicing, Titans. You're on your way to greatness. See you next time. 20.